Hello and welcome to our lesson about the special products of polynomials. So last lesson we looked at the FOIL approach to multiplying binomials and also the distributive property approach to multiplying binomials with trinomials. So now we are going to look at a couple special products of polynomials. There's more than just these two main examples, but these are the two most common that we will be looking at. So you'll notice that again, because these are binomial-based examples, that the FOIL method will work no matter what. So anytime, again, you're dealing with binomials, you can always use the FOIL method. The purpose of these special product rules are to give you some quicker shortcuts rather than using the FOIL method if you recognize any of these situations. So the first one we're looking at is known as the difference of two squares. The difference of two squares method is sometimes also called the sum and difference method, but the difference of two squares, and below here in blue ink, you'll see what the actual approach looks like in examples above it here. So if we have something like a plus b times a minus b, so a and b are the same values, but our first one, for example, could be like x plus 5, and then our second one would be x minus 5. So as long as they're the same binomial, the only difference is the plus here and the minus there. That's why it's sometimes called the plus minus or difference of two squares. So in this case, we could FOIL, and by doing FOIL, you'll see we end up with x squared minus 5x plus 5x minus 25. And when we combine like terms and simplify, we get x squared minus 25. So rather than using this middle step, we can jump right to this final piece with the rule right here. So if we know we have a difference of two squares, an a plus b times an a minus b, our final answer is always a squared minus b squared. So in this case, if we're looking at our top example, a is x, so a squared would just be x squared, and b is 5. So a negative 5 squared is a positive 25. So a squared minus positive 25, or x squared minus 25. For a perfect square trinomial, that means we have something like a plus b times itself, meaning squared, or a minus b times itself, meaning it's being squared. So a perfect square trinomial means our final answer ends up being a trinomial, 3 terms, and it's based on the idea of a perfect square being a plus b squared or a minus b squared. So our two examples here could be something like an x plus 5 squared, which again, if we wanted to FOIL it, we'd have x plus 5 times x plus 5. Using FOIL, you can see the math here, and then we end up with the final answer of x squared plus 10x plus 25. If we want to cut out the FOIL method, again, we can get right to this last piece by using this rule here. So if we have an a plus b squared, our final answer is a squared, so x squared, plus 2 times a times b, so 2 times x times 5, which is 10x, plus b squared, 5 squared, 25. For our bottom example, if it's a minus b squared, again, we could use the FOIL, x minus 5 times x minus 5, combine like terms, and get our final answer. Or we can use this rule here, and it's a squared minus 2ab plus b squared. So if it's an a plus b squared, it's a squared plus 2ab plus b squared. And if it's an a minus b squared, we have a squared minus 2ab plus b squared, which would give us our final answer here of x squared minus 10x plus 25. So if you feel the most comfortable using FOIL, do it all the time. If you want to save yourself some steps and save yourself a little bit of time, you can use these special product rules when you have these situations. So in our examples, you'll notice I wrote it out first using the FOIL method. So if I was looking at A, I'd have 3x plus 4 squared, which means 3x plus 4 times 3x plus 4. I can use the perfect square trinomial right here. A plus b squared is our situation. Or I could FOIL it, which you'll see here in the middle, and then the final answer. So if you FOIL, this would be your step in the middle, first outer inner last, and then you combine like terms. But I'm just going to focus on the blue font here. And how do I get from 3x plus 4 squared to my final answer using the rule? So we have a squared. 3x squared is 9x squared. 3x times 3x. 2 times a times b. So 2 times 3x is 6x. Times 4 is 24x. And then b squared at the end. So 4 squared is plus 16. In B, another perfect square trinomial, now it's subtraction. So again, I could FOIL it, which you'll see the step here in the middle, combine like terms, and I get my final answer. Or I can apply the rule, and a squared, so 9c squared, 81c squared, minus 2 times a times b, so 2 times 9c times negative 1, which would be a minus 18c, and then plus b squared, negative 1 times negative 1 is a positive 1. So with C and D, again, both perfect square trinomials. So in C and D, you'll see the FOIL methods in the middle, but if I was to apply my rule, I'd have a squared, so 4y times 4y, 16y squared, minus 2 times a times b, so 2 times 4 times a negative 3, and then our y, minus 24y, and then plus b squared, negative 3 times negative 3 is a positive 9. So a d, 2 times, 5k minus 2m squared. So I could use my FOIL method, or I can use my difference of two squares, and we would have 5k times 5k, giving us 25k squared. Then in the middle, minus 2ab, which would be minus 20k times m. And then the last part, plus b squared, negative 2m is a positive 4m squared. So you may be wondering why I flipped the order here. That's just putting it in standard form so that it's proper form. But it could be written as 25k squared minus 20km plus 4m squared. I just rearranged it to be in standard form. Now in example 2 here, you'll see we're dealing with the difference of two squares. So it's a 9w plus 3 times a 9w minus 3. Or like here, 11m plus 4 times 11m minus 4. So they're the same binomials, just different signs in between. So if I want to use FOIL, I can, or I'm going to keep in mind this piece here, a squared minus b squared. So if I have the difference of two squares, middle step you can see is FOIL, or if I want to cut that out, a squared, 9w squared, so 9w times 9w, 81w squared. And then minus b squared, negative 3 times 3. In this case, b squared, though, has to be a positive. So b is just positive 3. So positive 3 squared is 9 minus 9 because it's minus b squared. So 81w squared minus 9. In example B, 11m squared would give us 121m squared. And then B, 16, because 4 times 4 is 16. So minus that. So our final answer would be 121m squared minus 16. In C, A would be 6y, B would be a 5. So in this case, A squared, 36y squared, minus B squared, minus 25. And then in D, A is a 7x, and B is a 2y. So if we have A squared, 7x times 7x is 49x squared. And then 2y times 2y is 4y squared. So it's 49x squared minus 4y squared. So the purpose of these special products is in these scenarios where you have a difference of two squares or a perfect square trinomial, you can cut down the process of foiling and just apply these rules here.